I'm just gonna put the unit in, and this is gonna be seconds, right? So this gives us, finally, this is gonna give us 10 over 20. It's gonna be 0.5, excuse me, radian per second squared. Okay, so that's alpha.
Yes.
All right, let's go to B, quick. Number of revolutions that it makes during this time. This time around, okay, how many revolutions does it take during this time? Okay, and this is where it becomes a bit tricky. Okay, actually, it becomes tricky only if you don't recall something. There is an equation that kind of like relates velocity, acceleration, and what's this? Well, not rotation, distance. Okay. In this case, in other words, we're gonna have to go to Suvat, right?
Yeah.
Okay, what's the equation? There are four. I'm just gonna go to the equation that's useful here. This is gonna be S equals ut plus 1/2 at squared, right?
Yeah.
You remember this formula. Now, what are we gonna do? We are just gonna use the equivalence idea. What's the equivalent idea for S? This is gonna be your omega, right? Sorry, not omega. That's gonna be your theta, your angle, right? Your U is your omega, your initial omega, right? T plus 1/2 alpha T squared.
Okay.
Okay, so from here we get to this, and now we just put our values in. We don't know our angular displacement yet, so that's gonna be theta, right? And that's gonna be our initial is gonna be 5 radians per second. I'm just gonna put I'm gonna remove the unit for now. Our time is 20 seconds, right? Plus 1/2. Our A was 0.5. Then our T is 20, so it's gonna be 400. I'll just write 20 squared. Okay. So this is gonna give us 100 plus 400 divided by 2 is 200 divided by another 2 is another 100. It's gonna be 100. So our omega is gonna be 100 radians. Okay. But that
Is that 200?
Oh, right, you're right. So that should be 200, correct? Okay. All right. So anyway, that's 200 radians. What's gonna happen here? You're not being asked about the number of radians. You're asked about the number of revolutions, right? So what do? We convert this into how many revolutions? So 200 radians times 1 radian, not 1 radian, but 2 pi radians for 1 revolution, right? So the radian cancels out. So we're gonna do 200 divided by 2 pi. What's that? That's the calculator. 100 divided by pi is 31.8. 31.8. Okay. Revolutions.
Sorry, but what is revolutions?
Revolution is 1 turn.
Oh.
Okay. Okay, let's put that here. Revolutions is number of turns. Okay.
But,
all right. So okay. So you see, actually, at least before we get into the actual solving for torques, if you know like topic 1, or at least familiar with topic 1, this should still be familiar with you because this is part of topic 1, right?
yes.
Okay. So all right. So anyway, that's the idea. If you know the linear or the translational versions of all the equations, it's easy to translate that into rotation. For omega F. Okay, so again, the easiest equation to use in this case is the equation we used earlier, right? Okay.
Angle.
Yeah. So again, don't start with angle if you're struggling with it at the moment. Don't start with angle. Start with linear motion. So S equals ct plus 1/2 t squared, right? And then translate that, or not? Change that into the rotational versions. Change the only thing that won't change into the rotational version is the time, because time, right? Okay. Yeah. So let's do it here on the other side for number 2. Let's do it here. Okay. Yeah. So 2a. Let's just copy the stuff first before we do anything else. So omega I equals 0. Alpha is 4.7 radian per second. You don't know final, but you know that time. What was that? 20 seconds, right? Okay. And now we're gonna have to do this in revolutions per minute. So you can do one of two things. You can either change your acceleration into revolutions per second squared, or you can just do the final answer. Do it in the final answer. It's actually easier to do it in the final answer first. Yeah. So we keep our units as is. So we do the same thing. Okay. So I think this is easy. What do we do? This is gonna be v equals u plus et, right? That's the easiest version of the kinematic equations, the Suvat equations we have. Convert. So this is going to be omega f equals omega I plus alpha t. This is going to be 0 plus 4.7 times 20. And that's going to give us radians per second. What's that going to be? 4.7 times 20 is 94. Okay. Omega f is equal to 94 radian per second. Again, you're going to have to 94 radian per second times convert 2 pi radians into 1 revolution. So just in other words, you divide our answer by 2 pi. Pi, it's gonna be 14.96. Let's just round that off to 15.0. Okay, 15.0. Revolution. Undo it here. Okay. Now what I'm gonna do now is I'm just gonna multiply another conversion factor here, the seconds. 60 seconds, 1 minute. So in other words, you're right. You just multiply the answer by 60. Okay.
Okay.
Right. Minute. So second cancels out, radian cancels out. We're left with 94 times 60 over 2 pi. And that's gonna give us what? So 15 times 60. That's gonna be that's just 897 revolutions per minute, or that's gonna be 900 revolutions per minute in 2 sig figs. Okay.
Okay.
All right. Okay. So anything else?
For this one, no.
Uh-huh. So what else would you like to ask you?
So for 3, calculate time taken.
Mm-hmm.
I think I can do that one because
All right.
of the formulas.
So
I
we're
can try.
talking about number 3, right?
Yes.
Okay. So again, just tell me right now, which formula would you use, assuming that the angular deceleration is constant?
And we have revolutions and time.
Mm-hmm.
Probably.
You have, okay, let's identify. You have alpha from A, right? From part
Yeah.
A, right? Part A. What else do we know? We know time. Time. Actually, we don't know the time. You're looking for that, right? Okay. However, that's you don't need that to determine the equation you need, right? What else do you know? You have omega I.
Initial velocity.
Okay, initial. That's gonna be 1,800. And what else?
But no, isn't it initial 0?
That's final, right? Because it stops. That's final. Okay. So we don't need this anymore because we can solve t just with those things, right? All right. So last one here, and we're not solving. We're just setting up the solution. So what is the equation we need to use here?
Angle. No, it's final equals to initial plus acceleration times time.
Okay, correct. So you're just gonna use final equals initial plus a alpha t. Correct. So set it up, substitute that. Okay.
And what do I do with the revolutions per minute? How
Okay.
do I substitute?
What? Okay, you don't have to actually change anything anymore because in this case, as long as your units are consistent, it should be fine. Look here, your speed is in revolutions per minute, right?
Yeah.
And then your angular acceleration, it doesn't tell you to it doesn't tell you to translate that into radians per second. Okay, so the important thing here is, I think I'll just type that to make it easier. Make units consistent. Make sure your units are consistent. Okay.
Okay.
In other words, if I'll just use OW for omega here. Yeah. If omega is in radian per second, alpha should be in also radian per second squared. Okay.
Okay.
Now similarly, I'll just copy this. Generally speaking, there are certain ideas wherein, or certain times wherein you do the solution first, yeah? Before you do your conversions first. Generally, do conversions after solutions, okay?
Okay.
You have just play it by ear though. See if you need to convert first, okay? Okay. The last question you have here is the one with the airboat.
Yes.
Okay. All right. Let's get the first one. Let's put that in here. All right. Airboat problem. Okay. So okay. Outline why a force acts on the boat. Oh, this one's pretty easy. The first part. Okay. But let's see.
Yeah.
I've seen this problem before, just so you know. And I know how this eventually goes. This eventually goes into something not that easy, right?
Yeah.
Okay. So the first part, let's do that. So outline why a force acts on the boat due to the fan blade. Okay. Okay. I'll just put the last screenshot in and then we'll answer. Okay. Okay.
For the first one, I said that it's because the normal reaction force, but I'm not really sure what I have to include in the answer to get the marks.
Okay, it's 3 marks. All right. So the idea here is, first of all, when you see outline, right, you know what you have to do here. You have to kind of briefly describe what's happening. Briefly is the keyword here, right? Now, another thing here is when you see force, automatically when you see this combination of outline and force, always think state Newton's law. State one Newton's law. One of
Okay.
Newton's laws. Okay, so that's always going to be the first mark. Okay, so in this case, what am I gonna write as an answer for the first mark? Newton's. Okay, let me just make it bigger. So I will answer this like Newton's second law. No, third law. Okay, Newton's third law states that for every action, there is an equal and opposite reaction, right?
Yeah.
Okay. Okay, so that's 1 mark already. And the rest of this, to get the other 2 marks, the rest of it is describing what's actually happening. Okay, reaction. In this case, I'm gonna say, in this case, the fan pushes the air backwards, right? Or I'm not even gonna say pushes. I'm gonna change that to forces. Forces air backward, right? Okay. Okay. So I gotta ask. I know you tried to answer this before. Basing on this
Yeah.
answer, how many did you get?
I didn't mention the third law, so I think I'd probably get 2.
Yeah, you probably get 2. But again, don't worry too much about it. The grade boundaries are quite low for physics compared to the other sciences, right? So
True, yeah.
don't worry too much about missing 1 or 2 marks here and there, as long as you answer properly. Okay. All right, let's take a look here. Estimate the distance that the boat travels to reach its maximum speed. What information do we know here?
This is after the other question.
Oh. So it's this one first, right? Yeah.
Actually, the next one is about
Hold on, I don't have
the
that
mass.
shot yet. So let me see if I have that here. It's in the chat box. Okay, I don't have that.
So the question is,
Mm-hmm.
I guess it's in a test. The airboat is tied to the riverbank with a rope normal to the bank.
Mm-hmm.
The fan propels the air at its maximum speed. There's no wind. Show that a mass of about 240 kilograms of air moves through the fan every second.
Oh, okay. Question before we answer that, or before we attempt to answer that, have you learned the equation for a windmill or a wind turbine? If you haven't, we are unable to answer that question right away. Because I need to introduce to you that formula.
What is it? Maybe I know.
All right, let me just check. Wind turbine equation.
What topic is it?
This was under, in the old syllabus, this was under topic 8, which is energy production. Okay. I don't think that this particular formula will be used. Okay. Hold on. Is this it? Yeah, this one. I'll just copy the image here. To answer that question, you will need this formula. I don't think you've learned this formula yet, but let me show you. Okay.
Yeah.
Of the air passing through. Okay. Now, I'm just gonna tell you why we need this formula. In other words, we can't really solve this with what you know yet. Okay. The reason why we need this formula is we can reverse it, because in this case, this is basically telling us if the wind is pushing the wind turbine and it's making the wind turbine turn, this is how much power we can get. Which, if we kind of reverse the situation, instead of being the wind pushing the wind turbine, it's now the blades of the fan pushing the air. So it's gonna be, you're still gonna use this same formula but in reverse.
Okay, and why wouldn't it be correct to use like density equals mass over volume?
We can use that actually, but we're not given anything about the air, right? Can't recall.
We have density.
You're given the density.
And we have the radius.
Okay, so yeah, so here, and are we given the power rating of the fan, or how?
No, but it's not in the formula of density equals mass divided by volume.
Yeah. All right. So either way, since we're unable to solve this straight away, we can skip this for now. Yeah, we should be able to get some value later on.
Okay.
All right. Okay. Well, we're a bit over time at the moment, but are you okay? Just
Uh,
going through C. Let's just finish C.
I'm okay, but if you mind, we can even do it tomorrow. By tomorrow, I'll book another lesson.
Ah, all right, sure. Okay, that's fine either way. So we'll just continue tomorrow then. Right?
Okay.
Okay. So all right. So with that, uh, okay, just send me over that last question or that question 4B, just so I know exactly
Yes.
what to do. Okay. All right.
Okay.
Aside from that, though, I think we can end for today then. All right. So
Yeah.
stop the share first. Okay. So I'll see you tomorrow. You have a good day. Yeah.
Have a good day. Thank you for the
All
lesson.
right. Bye bye now. See you
Bye bye.
tomorrow. All right. So that's the end of the lesson there. Let's go back here. And we are gonna go back to this. Right, so that's the end of the lesson there. Yeah, I hope the audio is much clearer now. Because last stream, I think the audio was really, really faint, so I had to adjust my settings. I'll check later. I'll check the video later and see what the audio does. Okay, so anyway, so because that lesson's done, hopefully you learned something there. Anyone who's gonna watch this or who has watched live. But before we go today, don't forget to like, share, and subscribe to the channel. We're on. I bid you all now. Good morning, good afternoon, good day, good evening, good night, wherever you are in the world, and stay freaky, everybody. Bye bye now.